right now we have a working Next.js app with a GraphQL API, and we're interacting with that GraphQL API using Apollo client. However, we have one tiny problem. What if we have hundreds of links, maybe even thousands of links? Well, right now we only have 4 links in the database, so when I refresh, you can see loading appear very quickly and then disappear. But if we have more links, like thousands of links, this is going to take a long time to load because we will have a large API response, and this will result in a slow user experience, and we don't want that. And a solution to this problem is pagination. Pagination is the process of splitting your data into pages and then sending these pages as they're requested. Now, this is very common in apps like Facebook or Twitter, for example. So if I refresh, you can see that we're loading a couple of tweets the first time, but if I scroll, you can see that we're loading even more tweets. So this is pagination. Now, at the database level, Prisma supports 2 types of pagination. So if you go to the documentation, prisma.io/docs, and you look up pagination, you'll see that we have a page for it in the docs. Now, the first pagination type that Prisma supports is offset pagination. Now, with offset-based pagination, what you're doing is you're specifying 2 fields, a skip field and a take field. The skip defines how many items we want to skip. So say, for example, the first query, we return the first 3 elements, but in the second query, we want to return the next 3 elements. So what we will do is just keep skipping 3 items, and then we're specifying the take field, which just says, okay, how many items in the database we want to return, or like how many rows in a table we want to return. Now, this approach works, it's simple. However, it has some limitations. So offset-based pagination does not scale at the database level. So here the example is, say, for example, we have like 100,000 records, 2,000 records, and we want to just skip these 200,000 records. The database still has to traverse all of these records. So this is slow, and you will have a slow database query. Now, another pagination technique is cursor-based pagination, and it's the one that we're going to use for our GraphQL API to add to like the query that returns all links. So with cursor-based pagination, it's a bit different. You have a cursor. This cursor is like a bookmark or a checkpoint in your database. And what's going to happen is you're going to use that cursor to just jump straight to it rather than traversing all records when you're skipping. So here, for example, you will specify, okay, I want to take the first 4, and then in the next query, what you will do is provide a cursor, and you'll say, okay, I want to jump to the element that has an ID of 29, and then you will take the elements that come after. Now, with cursor-based pagination, there's just one tiny thing that you need to be aware of, is that you skip the cursor itself. So say we first, so like the first query, we return the first 4 items, and then we want the bookmark to be this last item. What we want is that in the second query to skip this element. So like you don't display it twice. And we're going to see how to do all of this in GraphQL. To implement cursor-based pagination in GraphQL, you should follow the cursor connection specification that comes from Relay. So this is an example of a paginated GraphQL query. And so this is a response, and we're returning a user, and each user will have friends, and we're specifying 2 arguments. The first argument is called first, and it takes a number. This is the amount of items that we want the API to return. So in this case here, we want to return 10 friends. And then we have this after argument, and we're passing an opaque cursor. So this will be, so the way pagination works is that you first have this initial request. And in the initial request, you're not passing a cursor. And then what happens is the return data contains a cursor for each item. And what you're going to do is pass the cursor of the last item to the second request so that at the database level, you can jump straight to it and not include the previous results. So this after argument, this is what it accepts. It accepts the cursor. So for us, we will be passing the cursor of the last item in the results. And what you see here, you have this edges object and this page info object. So page info contains information about like the page. So here we can have things like has next page. So this is a Boolean that will help us determine if we have another page or not. So how can the client know when to stop requesting when this has next page field is false? That's when you know that you've reached the end, and we're going to implement that. Now, this edges object is actually an array, and so like it's not an object. So like the field in this query is actually an array, and it contains it's an array of objects, and it contains a cursor and a node. So a node is the object type. So here in this query, the node is a friend. But for our case, the node will be a link, so like the link object type. And each edge in this edges array will have a cursor and a node. So this way, we can easily pass the cursor when we want to do pagination. Now, if this is a bit hard to comprehend, we're still going to be looking at code and covering it again, so don't worry. But yeah, this is kind of like the spec that we need to follow to implement pagination. We will have these two arguments. We will have an edges. We will have an edge object type. We'll also have a page info object type and a response object type. So let's go back to the code and start implementing pagination. Let's go to GraphQL, types, and then the link object type. So far we have the link object type. We will not change that. And we have the links query. And in this query, we're going to define the pagination logic. But before that, we're going to need to add a couple of object types. So I just added 3 object types here. The first one is edge, and it will have the name edge. And each edge object type will have 2 fields. The first one is a cursor. It's of type string. And it will have a node. And this node is of type link. And then we have the page info object type, and each page info will have 2 fields. It will have an end cursor, and it will have, which is of type string, and it will have a field called has next page, which is a Boolean. So we're going to return in the page info the end cursor of the page. So like the cursor of the last item in the page, so that we can pass it in like the next queries. And then finally, we have a response object type. So when doing pagination, like in this links query, so far what we're doing is we're returning the link type. But what we're going to do is instead of returning a link, we're going to return a response object. And this response object contains 2 things: a page info, which is of type page info, a field, and it also contains a list, and this list, so it's an array, and this array is of type edge. And yeah, so like we'll have a field called edges, and this edges field is going to be an array of type edge. So actually, if we hit save and the app is still running, and we go to localhost 3000 /API/GraphQL, and we go back to our code, in the schema.graphql, we should have these new object types. So again, we have this edge object type. It has a cursor and a string. It has a node, and it's of type link. And then we have the page info, which contains an end cursor field of type string, a has next page field of type Boolean. And then finally, we have the response object type, which contains a field called edges, which is an array of type edge. And again, this edge object type, this has a node, which is of type link, and a cursor. And then we're also including in the response the page info object. So yeah, these are the different object types that we're going to need. And now let's go back to our all links query. Now what I want to do is actually replace this links query with this new query. So what's happening here is that, again, this is of type query, and the name of the query will be called links, just like the previous one. And this query will return a response object. And it will also take two arguments, first, which is of type int, and after, which is of type string. We're just using this int arg and string arg functions that come from Nexus. And then in the resolver, I'm just returning right now static data. And what's going to happen is, so like this is a response object type. I have an edges array and I have a page info object. And yeah, this is what the response object looks like. So if I actually hit save and I go back to localhost 3000/API/GraphQL and I query my server, and I will see that now this links query, it has a first and after arguments. This is super nice. And I want to return the page infos and cursor has next page fields. And I also want to return edges. I want to return the cursor and the node. So, and in each node, I want to return the title, URL, description, image URL, category. And let's just remove these fields. And now when I run, and now we have links first, links after. So it doesn't really matter because we're returning hard-coded data, but we're going to test it with proper values for the first and after arguments. So now if I just hit run, I get the hard-coded data that I have. So right now this works. Now it's time to actually add the logic for Prisma to add support for pagination for this query. So if I go back to the code, and what I want to do is replace this query with the following code. So I just added the final code for the resolver, and there's a bunch of logic, but don't worry, I'll go over it and explain everything. But before that, we need to understand kind of like what we're trying to achieve. So the first thing that's happening is the client will call this query. The client sends a request. And we have one of two scenarios. So let's just write it down. Say client sends a request. This request can either be, this can either be the first request. So this first request is that when I go to localhost 3000 or like the URL of my deployed app, I want to fetch certain amount of links. And what I'm going to do as the client is I'll just send a request. I won't be passing in any cursors because I don't have any. And this is the first scenario. The second scenario is that I already sent an initial request and I want to fetch more data. And to do that, what I will do as the client, I will send another request, and inside, and this other request will contain a cursor. And on the database level, so what I'm going to do, like in the resolver, is check, okay, do we have a cursor or not? If we have a cursor, we're going to jump straight to it and then return the amount of items that we want to return. This is specified in this first argument. However, if we don't have the cursor, then we'll just return the first items in the database. So this is the first part of pagination. The second part is the page info object. So how can the client know whether or not we have more data? And to do that, the first thing we do is that, so like, let's actually now jump straight to the code. So the first thing I'm doing is I'm checking if we have a cursor. And if we do, I will just say query results. I'm setting this variable, initially it's null. And I'm just saying context.prisma.link.findMany and take, I'm specifying the number of items that we want to return from this first argument, and skip because I'm skipping the cursor. And then I'm passing in the cursor, and I'm just saying that the ID is args.after, which will be passed from the client. And if it exists, we're going to run this query, and query results will have links after the cursor. However, if we don't have a cursor, so the client did not pass a cursor, what we will do is just say query results equals await context.prisma.link.findMini and take the amount that is specified in the args.first so we're going to check for the value of args.first. Now here's the thing. This is the initial request, or if we're now what we want to do is determine, do we actually have more links? And if the query results, so say for example, we actually send a request to the database and we don't have any links, this will return an empty array. So if query results.length is greater than 0, we're going to see what actually happens if it's less than 0. So if it's less than 0, what we're going to do is just return this empty response object, because that means that, okay, we don't have an end cursor, we don't have any next pages, and we have an empty edges array. However, if we have results from this initial query, what we're going to do is actually fire off another request to the database. So we're going to have this second query results. And so what we're doing is, first, we're getting the last element in this initial request that happened in this block, and we're then getting the cursor from this last element. So what I'm doing is I'm saying last link in results, and I'm just saying query results, and then I'm just accessing the last element by saying query results.length -1. And then I'm just grabbing the cursor of the last item. And what I'm doing is I'm sending another query to the database while passing this cursor. And what I'm going to do is have this result object. So now the result object will contain my query results, the original query results, and I'll be able to include the cursor and be able to determine if we have more pages or not. And that's it. Now, this is a lot, so make sure that you go through the code. But a quick recap, what we're doing is, first we have this query results variable, it's null, and we're checking if we have an after argument passed from the client. If we do, we're going to just fetch the links from the database, starting from the cursor and taking the amount of items that are passed in this first argument. But if we don't have a cursor, then this means that this is the initial request sent from the client. And what we're going to do is just return the first items in the database depending on this first argument that we have. And then what we're going to do is check, okay, do we actually have results? So if either one of those, do we actually have links or not? And if we don't, we're just going to return an empty response object because now we just don't have any more data in the database. However, if we have data in the database, then we're going to include information about the next pages. So do we have more pages to fetch or not? And to be able to add the has next page field and also determine the end cursor, what we're doing is we're sending another request to the database while passing the cursor of the last item of the initial request. And then if this second query, there's more results, then we know that there are more pages to fetch. And if there aren't any, then we know that we ran out. So has next page, what we're saying is that second query results.length is greater than args.first. So say, for example, I want to return 10 items, but in my database, I only have 2 left. So after I run the query, it will say that there are no more pages to fetch. And that's it. So now if I save and I go back to my GraphQL playground and I refresh, so let me and I have now this query, I have this first argument and also this after, and I'm going to specify values here. So I want to return 2 links, and for the cursor, it's going to be null initially because this is the first request and this is what I want to do. So I'll just hit run, And it works. Let's actually turn this into a table. And we can see that this is the end cursor. We're going to use this value. And this end cursor is the same as this one. And we returned two values. And we have this field has next page and it's true, which is accurate because we have 4 links in the database. So now if we actually run this query and again pass this variable here, and then wait, it should be in a string, and then pass it. I think it's because it's in a new line. Yeah. So now if I actually run this query, what will happen is I should get different links. So now you can see I have this Prisma and I also have Apollo, but if I hit run, I have different links. And since we already have 4 links in the database, has next page is now false because there are no more links to fetch. And this end cursor is the cursor of this last item. These are both identical. So let me just make this as, okay, this is the maximum. So like this is identical to this. And yeah, so like now the API, the links query supports pagination, which is awesome. And now we're going to see how to actually send a paginated query using Apollo client. So now if you go to the index page, what we need to do is first update the all links query. So let's do that. So this query is the same as the one defined in the API. So we're saying that this all links query will take 2 variables, or will accept 2 arguments. We're saying first, which is an int, and after, which is a string. And then we're going to pass these 2 arguments to our links query. Now, what we want to do is that we want to specify the first argument, and we can do that by just passing in an object, and we have variables. And this is an object, and we can just say it's called first and say 2. So like when the query initially runs, we're going to fetch just 2 links. Now, to be able to fetch more links, what we're going to have is we're going to have a button that when clicked, we will send another request to the API. And now with Apollo client provides a really useful function. It's called fetch more. And we're going to use this function to fetch more links. So now what I want to do is actually update the markup for this component. So the first thing that I did is I pulled the end cursor and has next page values from data.links.pageinfo. And then what I did is, again, I'm just looping over the data. I'm just saying data.links.edges. That's because we will access it this way. The data is edges, and this is an array, and we're going to loop over it to display the links. So that's what I'm doing right here. I'm saying data.links.edges.map. And then for each node, I will be creating an awesome link component. And then I'm using the hasNextPage field, which is a Boolean. And if we have a next page, we will show a button. And on click, we're going to call the fetchMore function. And the fetchMore function, it takes the following arguments. We have variables, and the variable that we're passing is the end cursor. So we're saying after end cursor. So this way, the API, when the resolver executes, we're going to have an end cursor. And then we have this update query, and this is responsible for updating the UI. So we have previous results and fetch more results, and what we're doing is just we're combining them together by spreading them into this array, and then we're returning fetch more result. However, if hasNextPage is false, so we don't have more data to fetch, we will say you've reached the end. And actually I have this extra curly brace. And that's it. So now, if I hit save, let's see what happens. So the app is still running. And if I go back to now localhost 3000, I fetch the first 2 links. So this is because in the use query, I said variables first 2. And technically I can say variables first 1. And then when I refresh, I should only have 1 link, and that is what happened. But let's go back to 2. And now, if I click more, I should have 2 more links. That's because that's what I specified in the first variable when I passed it to the useQuery hook. And when I say more, I get 2 links. And since we only have 4 links in the database, we've reached the end. And that's it. This has been pagination both on the server and on the client. And yeah, in the next steps, we're going to see how to add authentication so that only users who are logged into our app can actually see all of these links. And then we'll see how a user can bookmark these links. And we'll also see how an admin can create new links so that we can add them to our app.